I'm live? Cool. All right, thank you for coming out. Am I too loud on this? Is that good? It's good? All right, cool. Thanks for coming out to Notacon. Thanks for seeing my presentation. Sadly, this might be the last Notacon. Last year was the first Notacon I ever went to, and I kind of really like the whole concept. That's me. Follow me at Twitter, Alex Escott. That's a picture of me getting, burning myself with a laser. That's on my Twitter profile. But I'm basically an IT specialist that works at a credit union. Hobbies of Wi-Fi, Linux, open source software. I love quantum mechanical stuff like lasers, RF, and magnets. You know how they work. I don't know. How do they work? Miracles, I guess. Pretty well. So to start off, topic's kind of short up there, but it's basically wireless mesh protocols, and in a society absent of net neutrality, how it benefited. So I'm going to basically start off with multiple topics and then kind of branch it all together on why I'm explaining these different approaches. But first is wireless mesh protocols, all the different types. Basically, then I'm going to go into one called Batman. It's a better approach to mobile ad hoc networking. Then I'm going to go into what is dark fiber, what is net neutrality, and how to regain the internet. So the problems with wireless. With wireless, especially in the routing realm, you don't have the same standards that like a Cat 5e cable will work at a certain range or not. With wireless, you have different types of modulations per the signal. You also have outside variables, so you really can't create a good method to actually take the data and ensure that it's going to get somewhere in the perfect sense. The fix for that is basically build a better routing protocol, something that accounts for intermittent connections, something with the least amount of overhead, and best ability to dynamically scale. So basically in 1999, there was a RFC that was created called Mainnet, Mobile Ad Hoc Networking. It's kind of not really an RFC in the sense of like its actual protocol. It's more of a concept that was created that people went by as a guidelines. And since 1999, various people tried creating different approaches for the best type of mobile ad hoc network. So what is a mobile ad hoc network or a mesh? Basically, what it is that it's most people deal with like cell phone towers or your access point at home, which is all an infrastructure base. So you're connecting to one single wireless entity, and then you're using that device to take your data and route it wherever it needs to. A mobile ad hoc network is basically a decentralized approach where every device is its own router. So if my cell phone connects to another device, it will actually take that data and move it over to another entity. So types of a ad hoc network. You got basically proactive, which is table-driven, reactive, on-demand, and suboptimal, which is something that doesn't exactly fall in either of those categories. So proactive routing. Proactive routing basically contains a smooth, fresh list of all their destination routes. So basically, it maintains the whole routing table on every device, which gets pretty bad because with mobile devices that come in and out all the time, you're going to be dealing with a lot of noise. So like say a device drops, it's got to go tell everyone and their friend that it's dropped. So you're going to deal with a lot of excess flooding for that. Basically, the approaches that use the proactive are OSLR, which is Optimized State Link Routing, DSDV, and OSPF. The other one is reactive routing, which reactive finds its routes when the actual request happens. It basically creates a lot of high latency. So in order for me to take a piece of data and move it somewhere, I have to create those routes, and there's a lot of actual delay time for that. It's great for devices that sleep a lot, so you're being more conservative with energy. But overall, it's kind of a harder approach to actually get real-time routing, and also something that isn't really going to cause a lot of flooding too when you actually each time you route a data. Oh yeah, the ones that actually use that are DSR, ADOV. The ones that actually use reactive is DSR, AODV, HWMP, which is basically 802.11s standard. So suboptimal, something that doesn't really fall into either of those categories. For example, there's a hybrid called Zone Routing Protocol. And there's also one called Batman, which is considered proactive, but in the sense, it doesn't operate in the same. So Batman is a decentralized mobile ad hoc network, just like everything else. It's a layer 2 routing protocol. A lot of the other ones are actually layer 3. And it was developed by Freifunk, which is basically a German grassroots free radio group that was created. So how does the routing protocol works? Essentially, no single node knows all the information, doesn't know all the routes. What it does is it reaches out to its neighbors and or basically says, I need to send this data packet here. So it goes to the actual neighbor, and that neighbor basically says, okay, I know where to go with this. So in a sense, it's more of a decentralized, democratic routing protocol. An example would be if you guys are from around here, if I'm in Canton, I'm traveling to Akron, I don't need to know about 271. That's up in Cleveland. Most of the other approaches basically say, well, I know you need to get up to Akron, but you need to know about 271, which doesn't portray into anything that you do. That's what the other approaches do. This one basically just takes in, okay, I need to get over here. Okay, I'm going to reach out to this guy. This guy knows where I go on 77, done deal. So, like I said, it's a layer 2 routing protocol. It's on the data link layer. It was incorporated into the Linux kernel so that you don't actually have much latency for that. So instead of actually having something that's on the user space that requests the kernel drivers to communicate, it's all on the actual kernel level. So you don't have to actually spend more time requesting a process when it's already there. It basically encapsulates the data in the packet, so it creates a little overhead on the actual data diagram and uses that as its routing algorithm. So basically, OGM is originate message, which, like I said, it's the actual overhead of that packet, which contains all the routing information, like the link quality of the device that it's communicating to. And then when it goes to the actual other device and it sees that, it requests back an ELP, an echolocation protocol, to actually incorporate, okay, this is where my best routes are, this is the actual signal quality of my neighbor, and this is the best approach to take that data to the next level. With Batman, there's ongoing work with the actual routing protocol. Still, the actual fundamentals sometimes change a little bit. The latest one, they actually did change the OGM on how multi-link optimization works. But since it's doing that, it's still considered experimental. There's constant add-ons too, like network coding, basically just taking the actual data and kind of creating like relays, so to speak, so that you actually send out a bigger data packet so you're creating less airtime, though you do increase the latency with that. There's distributed ARP tables, so if you have a mesh client versus a non-mesh client, it'll actually cache that information better. And multi-link optimization, which was added to recently, to actually incorporate multiple radios so that it actually send data properly through each one. So it's kind of like channel bonding, but since it's not anything to do with one big piece of data, everything kind of works on its own. So what is dark fiber? Simple. It's just basically fiber that was never used. Unlit. Well, I mean, it could have been used, but it's unlit cable right now. During the telecom boom in 1990, various people laid down a lot of fiber, and they laid down an abundant amount. It's due to the fact that 80% of the actual cost of laying down fiber goes all into labor, like 10% into the fiber and something else too. So there's apparently a large abundance of this out there right now, and I assume a lot of it's still, a lot of people are going in there and utilizing it. This was also in 1990 where they laid it down. They didn't have technology such as like wavelength wavelength division multiplexing, which basically instead of actually just sending one light beam down, using that for your high-speed modulation, you actually multiplex and demultiplex on each end of the fiber, and you actually get a full color spectrum. Well, not color spectrum, but a full spectrum. And you basically get about 160 times the amount of bandwidth per device. So there's a lot of actual abundant resources out there for internet infrastructure. So what is net neutrality? In all honesty, it's a very vague concept. It's really something that really hasn't changed since it started coming out. It basically means that all data is treated equally. ISPs and governments treat data the same. Many people concerns is basically with net neutrality that's quote unquote being dead with the FCC ruling that happened recently. A lot of people are worried about their internet service providers becoming like mobile carriers now, where they'll be able to nickel and dime you for every megabyte. In all honesty, it's not as much of a concern. It may sound a little bit like a hypocrite, but you gotta understand that in sense of a utility consumption way. Does anybody know what a cartel is? Thanks. A cartel is basically a fixed agreement between various different companies that basically, fix marketing, fix prices, fix production. These usually happen in oligopolistic markets or industries such as, the cell phone, U.S. cell phone carrier. So what does that exactly have to play in with this? Essentially, with no control with net neutrality, not only ISPs could actually control and maintain the bandwidth you receive, but they could also control the content providers. So, and here's a good example. If Comcast feels Netflix is competing with their Hulu, they could honestly just start charging a huge amount of an IP transit fee to actually use for those providers using Comcast to actually use Netflix. The thing is, the end user will never see that. The end user will only see the fact that Netflix price is going up higher, and they don't know why. So it becomes a very big issue for any content provider such as Netflix, Amazon, Google, various other ones out there too, that any of these ISPs could actually make them fold by backdoor deals, saying that I decided to go with my own version of this content provider, and I'm gonna basically screw you over from using my type of internet traffic, and thus the death of creativity. So how do you fix this? Basically, just go around talking to other people about it. If it really concerns you and you feel that it may be a big issue down the road, just start talking. That's generally the biggest way to actually spread information. The other thing is talk to the government about it. FCC is the one that regulates this, but there's other providers in the government too that would help incorporate that. So if it's a really big concern to you, reach out to that. Also, the other approach would be create your own internet service provider. It's really hard because the actual market to entry for ISPs is ridiculous with all the lobbying and controls that the ISPs have. That's generally the reason why you only have one provider in your area. But between all the dark fiber that's out there and using wireless mesh protocols, basically bring fiber to the premises so you have a lot of bandwidth coming in there, and then branch it off through wireless mesh protocols so you could actually just build a big grid of the internet. So, on to questions. Does anybody have a question to go ahead?
Since all the devices would simultaneously act as clients and routers, and most of those devices would be mobile technology, they would flip them on and off throughout the day, etc. Isn't there a high chance of exploitation with mesh technologies if you don't have at least some kind of
Basically, what he's asking is, with mobile ad hoc networks, since there's no centralized format for it, and they're all kind of just bouncing off each other for network and routing, how's the actual security concern of that? Is that
One could monopolize all of the paths, and then anything within that range that connected to it,
correct?
it could fall somewhere else.
Okay, so basically he's saying that one actual node that's connected can capitalize all the routing tables since there's no centralized format. The approach would basically, the wireless would be, instead of actually dragging copper or reusing the copper for the infrastructure, you use wireless mesh, but it would still go back to a gateway. There's always going to be a gateway that actually monitors and controls all this. But as a security implementations for, because I'm at a hacker convention, I know you guys are going to ask something about security. Security implementations, you basically have different approaches. A lot of this stuff for like Batman, OSLR, they're all on generally like OpenWRT is one of the Linux distributions that actually use that a lot and kind of push that along. You look on a lot of the threads, they basically talk about WPA none. It's basically WPA encryption, but it passes the key on the actual network. Everyone's like saying, oh, it's just as weak as, WEP. Really, essentially, it's weak. It's just way weaker since the key's actually being passed. It's pointless if you're on the network. When you're outside the network, it's just as secure, but there's no point. You're going to be on the network eventually. So there's a new approach called IBSS RSN, which incorporates the standard WPA2 encryption. And it's just more recent into the actual Mac 802.11 on the actual kernel. And then there's also access point isolation, which is on a part of the actual routing protocol of Batman that basically takes your mesh clients and doesn't allow the mesh clients to talk to each other. They can only talk to non-mesh. So basically going across the board to the mesh, to the gateway, they're not going to be able to actually communicate between each other and steal information. The other approaches would basically be build your own Wi-Fi with unlicensed frequency bands. You could actually build your own device and have something kind of like Wi-Fi, or something like it that nobody else could actually use and utilize. And another approach is to basically buy an FCC license spectrum that nobody else could use and own that, and create a actual device that nobody in the public could actually use. I mean, obviously, anybody will eventually find a way to exploit it, try reusing it, but by that time you could deploy something better. And then kind of really, in all honesty, with security and how actually data is done, I honestly am a firm believer that the endpoint should be worrying about the security in between. It shouldn't really be much of a concern, but and then force people, start making people, always use SSL, or, I mean, it's kind of a standard now, but force everyone to actually use SSL, or if you're having some type of private information, use some type of tunnel, which really doesn't help a whole lot with the whole new OpenSSL breach, but so does that kind of answer your question a little bit in that sense, or?
Yeah, I was more concerned with the ability for the local device to actually hard poison or something, basically telling them that I am the gateway, and that once it gets to me, then I can conflict with whatever local connection I have.
I see what you're saying. Yeah, you could, like I said, with API isolation, kind of break that away from people actually being part of the mesh, and then with the mesh itself, you could actually encrypt every traffic. So you could be like a company that sells this equipment, and then you maintain it and and then when you sell the equipment, nobody else has that encryption between them. So there's no way for them to actually go in there and spoof that, because, well, I mean, I'm sure there will eventually be security. It always gets broken, but it gives it a lot more secure approach for that. Any other questions? Okay.
So, while the devices are being mobile, what is the static way of overhead affecting the battery consumption?
This is not necessarily for like mobile phones. It's more designed for building an infrastructure using wireless devices. So it's something that's going to be plugged in all the time. The benefit is that you're not actually using copper lines. You're not using limited equipment that's kind of old telecom issued equipment. You're building a new infrastructure that doesn't have to have somebody come out and dig up a whole yard. You can use it for any type of mobile device like your phone, but like you said, it's going to be a lot more consuming on your battery life, and generally you can't really put it to sleep that easily, because if you do, then you have to re-update the routing tables.
Yeah, my next question was going to be, like, with everything being sort of a heterogeneous mix of I'm running this firmware, you're running that firmware, you're running this iOS, you're running Windows 8.1, I've got signage on something or other. How would that work? Like, it's not for things like phone.
Yeah, it would be more for kind of somebody to provide a better solution for an internet service provider. You can, like I said, use it for entities like such as just home personal use, stuff like that. But when you're incorporating because there's different versions of Batman, and some of the actual routing algorithms that are older don't work well with the newer stuff, and vice versa. So like you explained right there, you're going to come across some complications with that.
This would be something like a Batman and traditional endpoints will on device, be able to hop on that network, does it have to have a translation between
Basically, what he's asking is the actual device. How is it able to hop onto it, and is there some type of way of translation? Essentially, without any type of encryption and basically blocking it out. So if you just have Batman kind of in the open, if you have another device that actually use the routing algorithm, it could just jump on there and use it. So essentially, yes. But that's nothing to do with the routing protocol. The routing protocol has just like anything else, it really doesn't deal with encryption. The encryption is a separate layer that actually deals with how it actually communicates and syncs. Yeah. This specifically, what he's asking is how are we going to get around the issue with 802.11 and the limitations of it. And this routing protocol is a layer 2. It really doesn't care a whole lot about what you're using. You could build your own FPGA and build your own wireless standard and use this. As long as you're able to use a Linux driver that actually communicate with the actual routing tables or routing algorithm, you're not limited to just Wi-Fi. You could even do it on WiMAX. The complications, though, as of an entry, is that you have to be a large company and really understand how Wi-Fi works to build your own FPGA. So the average person probably will start off with Wi-Fi and then become successful. But even with 802.11ac and the FCC opening up more license for the FCC spectrum, because they have another 100 megahertz they're adding on the 5.8 gigahertz channel, you have a lot more bandwidth to provide. You could get about, with the whole spectrum, you get about easily a gig or more. And you could use that for kind of multi-link, so you could have kind of one for sending and one for receiving and backhauling and a bunch of other things. Does that answer your question then?
Yes, thanks.
Okay. Open, what was that? Beats? Oh, I'm not sure much about the OpenBTS. Sorry, I can't really say much about that. Any other questions? Go ahead.
We're going to set this up with the home network just to try and evaluate it and everything. Are there specific requirements for the cards for clients, or is it all based on the browser? Or then you said use WRP for a lot of that, the devices, but what about for the client side?
What he was asking is basically, if he wants to set up his own version at home, what are the requirements for the actual devices, and how do you set it up with what you have already at home? With the actual mesh protocol, it's going to be Linux based, so you're kind of guided around to what's currently, you can't use some weird chipset that doesn't work and doesn't have a Linux driver. So most of the devices that you see on the internet, like Broadcom, Ethereos, will work with this. A lot of people will use Ethereos because there's a lot of good support for it. And then you're also limited to actually running a version of Linux on it. A lot of routers will support OpenWRT. You could, I think, run Batman on DWRT. Really, essentially anything with Linux on it, because it's actually in the vanilla kernel, Batman. So the Linux version, you can actually put it on there, just as a support for the distro. Some of them don't have it out of the box. Any other questions? All right. Oh, go ahead. Yeah, what he's asking is if FCC, the TV, was it the broadcast TV bands for frequencies was open, and if that's available and use. As of like Wi-Fi standards, they don't use that, and many different standards don't use that. I don't know if they. I think that's like what's the frequency? Like the 700 megahertz, something like that. That was sold. Okay, so it was open for license and then rebid and sold then. But okay, but there's a lot of providers out there that are kind of using frequencies that are not really using frequencies that FCC, I think, is actively going in there and trying to reopen a lot of these frequencies back to the general public. A lot of them get bid on, and sometimes they become incorporated into open unlicensed standards. Like I said, the 5.8 gigahertz added 100 channels of bandwidth to it, so it makes it a lot faster. So you'll start to see 802.11c AC devices actually have a lot more bandwidth because of that. All right. Any more questions? All right. Well, thank you all for coming out, and I hope you get some valuable information out of this.